Imagine a desktop pet that's more than just cute. It's your constant AI companion, shows you the date and time, answers any question on your mind, and even keeps an eye on your desk when you are away. If someone touches your belongings, you will know instantly. With vision-based AI, it can actually understand what it sees, something most off-the-shelf pet bots can do. Sounds futuristic? It's real, and in this video we'll show you how to build your own desktop pet bot from scratch.
Hello everyone, welcome back to a new video at Sparklers. We are the makers, and today we are going to show you how you can build a desktop AI-based pet bot like this. So nowadays we are seeing that many people are building desktop pet bots and selling them, but we thought why not building a desktop pet bot with a camera with AI features and also to show you how you can build your one. So in this video, we are going to do that. We are going to show you how you can build this one. So we call it KIKO, and KIKO has a small screen. And as you can see in the small screen, the beautiful and cute eyes of KIKO. But you can show anything in the screen. Also, it has an inbuilt camera, so it can do live video streaming. And also, we can apply AI-based image processing on it. It has an inbuilt speaker, so it can speak. And like I already mentioned, it has AI features. So mainly we are using Whisper, OpenAI, this kind of tools. Using that, we can also do AI-based image processing, and all the features obviously I'll show you in the video. And also it has other features like it can tell you the weather, it can talk you like an AI agent, it can add your to-do list, it can add alarms, and a lot of things. And also it has a web dashboard where you can visualize the live video surveillance. You can see if it is capturing an image or not. You can check your to-do list, you can check your alarms and all the things. And at the end of the video, they're also going to provide you the 3D model for this, the schematic for it, codes we have used, and everything. So I think without wasting any time, we can start. But before that, if you haven't subscribed to the channel yet, please subscribe so that whenever we make another AI-based product or similar thing in future, you will get a notification. So now let's start.
So first we need to design the enclosure for our KIKO robot. We designed the complete enclosure in Fusion 360 and the file link will be available in the description below. Once the design was ready, we 3D printed it using white PLA on a Creality K1 Max printer. After printing, this is how the enclosure looks and it's now ready to be assembled. Next, let's talk about the components we are using. For audio output, we are using a 4 ohm 5 watt speaker with a 40 mm diameter. For the display, we are using a 1.3 inch OLED display with the SSD 1306 driver. As the brain of our robot, we are using the Zio ESP32 Sense module. The board is very compact and comes with a 3MP camera built-in as well as a mic built-in. Perfect for this project. You could also use an ESP32 cam here, but the overall form factor would become much bigger. For audio amplification, we are using the Max 98357A I2S audio amplifier. We are using a DIY metal touchpad for touch input, but you can also use a professional copper touchpad if you prefer. We also have an RGB NeoPixel LED, which already has wire soldered to it. And finally, we'll use the external antenna that comes with the Zio ESP32 Sense module. Now let's move on to the connections. First, we'll connect the OLED display to the ESP32. SDA goes to GPIO 8, SCL goes to GPIO 9, VCC goes to 3.3 volt, and GND goes to GND of the ESP32. You will also find the complete schematic on GitHub. Next, we'll connect the speaker to the amplifier. The positive terminal of the speaker goes to out plus of the amplifier and the negative terminal goes to out minus. Now we will connect the amplifier to the ESP32. Vin goes to 5 volt on the ESP32, LRC goes to GPIO 7, BCLK goes to GPIO 5, DIN goes to GPIO 6 and GND goes to GND. If you want to set the amplifier gain to 15 dB, you can connect the gain pin to ground using a 100 kilo ohm resistor, but we have connected that directly. Next, we will connect the touchpad to the ESP32. We have soldered a wire to the metal touchpad surface and that wire is connected to GPIO 4 of the ESP32. Now coming to the RGB LED connections, the red goes to GPIO 2, the green goes to GPIO 1, the blue pin goes to GPIO 3 and GND goes to GND on ESP32. After that, we simply connect the antenna to the ESP32 module. Finally, we can place all the electronic components inside the enclosure. We need to be careful regarding the wiring, and finally we can close the enclosure. And that's it. Our KIKO robot is now fully assembled and ready to be programmed.
So now KIKO is completely assembled and it's ready to upload the code. But before we upload the code into it, I'll talk about how the overall system is working, from where you can get the code and all these things. So coming back to my system, as you can see, this is the GitHub repo of KIKO. I'll put the link in the description. So here, as you can see, you are getting all the things. So basically this are here, you will get the Arduino codes here. Next, you also going to get the 3D file if you want to 3D print it. Also, there is a README. Now in the README, we have documented almost everything. So you will get the features, the hardware components, the full connection of each and every component. Then you are going to get the connection diagram. Then you will get the system flowchart. Now let's talk about the system flowchart, how the whole system is working. So as you can see, it's touching with the copper touchpad. So basically there is a touchpad. Once you press the touchpad, then the user interaction will be started. Now there are few kind of user interaction available. One is if you single tap. So if you single tap, it is going to switch the modes between. So there are two modes. One is the eye animation mode, and then there is the date time showing mode. So if you just single click on the touchpad, it is going to switch between these two modes. Now if you do double tap, then it is going to start the video surveillance. Okay, so if you just do double tap, it will start video surveillance, and then you can go to the web dashboard and check the video, live video feed. And then again, if you just touch it once, then it is going to stop the video surveillance. This is another kind of user interaction. And the third one is if you just hold the touchpad. Okay, so if you just hold the touchpad, then what will happen? Till the time you will hold it, the system is going to capture the audio, and then it is going to send the audio to basically here we are using Whisper STT to speech to text. So here we are, so basically it is going to take the audio chunk and going to send to Whisper. And from there, from the speech, we are going to convert it to text. Then the text, we are going to do the reasoning using GPT-4o Mini. Now, reasoning means there can be two things. One is we are giving it a command. For example, we can give it a command like tell me the weather, do this Google search, or maybe add this to the to-do list, or maybe add this alarm. This kind of action can be one thing. And then there can be normal talking, right? So if it is normal talking, in that case, what will happen that from GPT-4o Mini, it will do the reasoning, and from there it is going to get another text output, and that text output we are going to use the Google text to speech, and using Google's text to speech, we are going to convert that text to speech, and that speech will be played in our system. Okay, so as you can see, so from the natural language generation, it will come to the output where basically in the OLED some face animation will be there, and also through the I2S speaker we are going to get the audio output. Now if it is action, in that case what will happen that you tell me the weather, then we are using some other APIs. For weather we are using one API, so those kind of APIs will get called. For example, for Google we are using one API to do Google search, because with ChatGPT you cannot always get the latest news, so with Google we are getting that. So there we are using Google APIs. Or for example, if you ask it to take a picture and tell me what is in the picture, that it can do it. So in that case, we're going to capture a picture and going to send it to GPT-4o Mini and get the output, and again going to do the text to speech and say. So these are some actions. So either it will be a natural language normal talking, or it can be actions. So in these two parts, the system is going to work. So this is how the overall flowchart is, and then finally there is a dashboard. In the dashboard you can check the status of KIKO, that if it is speaking or it is thinking. Then there is a gallery where you can check if basically the pictures it is capturing. There is a camera where you can check the live surveillance once the live surveillance is started. In the chat you can check your previous chat history. Then finally in tasks you can check if there is a to-do it has added, or there is an alarm it has added. Those kind of things you can check. Okay, and all the data currently it is storing in the snips of the ESP32. So locally we are storing everything, and also you can clear the memory. So this is how overall the thing is working. Now I'll show you the code. So here let's say I go to inside the KIKO folder, and there if you check there are multiple things. Now the thing you need to be bothered with, if you're making the exact same thing, you just need to go to secrets.h, and there you are going to get all this API keys. So you need to put the Wi-Fi SSID, Wi-Fi password, so that it can connect to your Wi-Fi. And next you need to provide OpenAI API key, Open Weather API key, Google Search API key. Now OpenAI mainly are using for Whisper and the OpenAI part. the open weather you are using to get the latest weather information, the Google search API to do some Google search and all that thing. Okay, and if you want to do OTA, then also OTA hostname password you can put here, but that is not compulsory. But OpenAI is the main thing here, because without OpenAI you cannot do the reasoning or the speech to text part. Okay, this is about the secrets.h. Now going back to the main file, which is KIKO.ino. If you go to here, you are going to get this a very long code, so I'm not going to explain you line by line. Overall, I'll tell you what's happening. So key features you can already check. I already discussed that there is this record, then from the record going to whisper transcription, from the GPT-4 chat, and from there Google TTS playback. That is the overall flow. Then there are alarm, camera, display, all the things are there, and also everything you can read from here. Coming to the code organization, I'll talk a little bit that here, as you can see, from which line to which line, whatever written is has been documented here. So for example, embedded web UI, the configuration, utility function, WebSocket, audio processing pipeline, HTTP request handlers, everything has been written. So you can just go to a particular part and you can check. Also, if you want to change the UI a little bit, you can do that. You want to add multiple more new functions, you can do that. Okay. So this is how overall also the dependencies has been noted. So audio library, what you need, JSON parsing for OLED graphics, for file storage, all the things has been noted. So you need to install those libraries obviously. And once you install all the libraries, so I'll show you while uploading the code, but once you upload all the libraries, you can simply go and upload this main KIKO.ino file. These 3 remaining files need to be in the same folder. Okay, so don't think you can just have the IONO file you upload. No, these 3 files also you need. So these 4 files need to be in the same folder, and from that folder you open it in Arduino IDE and you can upload the KIKO.ino file. So that is the only thing you need to do, and before that you must have to change the secret.h file. Now how you can get OpenAI API key, those I'm not showing because it's very simple. You can just go to Google search and you will get it. And also initially for first time users, you will also you will get some free credits, so you don't need to pay anything. So you will get all free credits, with that you can build it. So this is how about the code is and the overall flowchart, how the system is working. So now we are going to open the Arduino IDE, and from there we are going to upload the code in KIKO, and then I'll show you a live demo. Okay, so here I am on the Arduino IDE, and as you can see here, I have already opened the file here. Okay, so you can see the 4 files, so KIKO.ino, so here as you can see the remaining 3 files. So those files should be in the same folder like I already mentioned. And next you need to select the port. So as you can see here, already showing that ZAO ESP32S3. So you can simply, you are unable to find, you can simply go to board. From there you can just go to ESP32, and from there you will find it. So here as you can see, ZAO ESP32S3. And if ESP32 is not available, then you need to download the ESP32 files. Okay, that you can do easily. So from board manager, you can just download the ESP32, and then from there you will simply get the 32S3. You need to select the port accordingly, or Windows nowadays does it automatically. You don't need to do anything. Another thing you need to change, that is you need to go to the PSRAM. You need to select the OPI PSRAM. And that's all the thing. And also another thing you need to do, that is there are a lot of libraries we are using. So if any of the library is not installed, then you need to install it, and for that you can simply go to manage libraries, and from that you can just search for any of the library and you can download them. So and once you have downloaded, we are ready to upload the file. You can simply click on upload and the code will be uploaded.
Finally, once we upload the code, KIKO will first connect to the Wi-Fi network, and after connecting, it will display the assigned IP address on the screen. Within a few seconds, the system finishes initialization and KIKO will be ready to use.
So I'll show you a demo of the KIKO. So basically, as you can see, currently it is showing the time and the date, as well as we can see that it is connected to a network. If I click it once, so as you can see, now it will show you this face animation here. And this is the dashboard of it. So you can simply just open the IP address of this one and you will get the dashboard. And this is how the dashboard basically looks like. So it has a status. You will see the previous chats. It is a gallery option. There is a camera for live streaming, and also there are tasks. Okay, so I'll show you each one. Just, if I have to show you the live streaming option, so if I click it twice, so as you can see, live streaming, and you can see us and everything we can see. So this has started the live streaming, and you can check it from here. Clicking here twice,
I have stopped watching.
So it has stopped this live surveillance. Next, you can ask it any question. So for example, if I ask, so if I have to press it and hold it, and then you have to ask the question. So if I ask, let's say, who is the Prime Minister of India? So as you can see in the live transcription, it is showing who is the Prime Minister of India.
Prime Minister of India is Shri Narendra Modi. He took office for the third time on June 9th, 2024. If there's anything else you'd like to know, just ask.
So this is how it answers. Now if I go to chat and if I see in the history, I can also see like what I have asked him, what it has answered, all the things. So this is to show you that the AI based image processing part. So we can simply say like what you see, and basically it will show us what is in seeing, and also it will show the image here. So for example, what do you see?
Sure thing. Let me take a look.
So as you can see, it is capturing an image, and there as you can
It
see.
shows two people, with one person holding a camera and taking a photo while the other is partially in view.
So as you can see, this is how the AI-based image processing actually is working, and so we can do anything else with it instead of just doing what you can see in the picture. And now coming to the task. So for example, I can just say, add in my to-do list that I have to make a YouTube video today.
I've added make a YouTube video to your to-do list.
So as you can see, it has added
If there's
that.
anything else you need,
No.
just let me know.
Okay. So as you can see, it has added the to-do list to make a YouTube video. Similarly, we can set an alarm. Add an alarm at 6 p.m. today.
Perfect. I'll alarm you at 6 p.m.
So as you can see here, the alarm has been set, and as you can see, it's showing that 18 minutes 52. So basically this is showing the remaining time. So it is 5:41. So it is showing that this much time is left of my alarm. So this is how, and we can also simply clear it in this way. So we can just cancel the alarm. We can clear the to-do list too, and this way basically it works. So I hope you have enjoyed this video, and thanks for watching this video. So this is how you can make a AI based pet bot of your own. If you have any query, any question, please let us know in the comment. We'll try our best to answer you, and many more this kind of projects. So ESP32 based, Jetson based, Raspberry Pi based, many projects we are building now. So please subscribe to the channel so that whenever we make a new project, you will know that. And that's for all about this video. See you in the next video. KIKO, when I will get married?
I wish I could predict that, but I can't see the future.